The angle of elevation of the top of the tower standing on a horizontal plane from point A is alpha. So we are having a tower like this, and for this we are standing at point A, let's say somewhere over here. So the angle of elevation from this particular point is alpha from the horizontal axis, or I can say ground. This is alpha. If we move some distance, let's say this is the distance we moved and we reached to a point somewhere over here. Now the angle of elevation is changed. The new angle of elevation for this is beta. What they are asking, they are interested in calculating the height of the tower. This is h, which is the height of the tower. So let me assume this distance of the new point from the point just below the tower, or the feet of the tower, is x. So we are having two triangles as usual with the method which we follow, that is tan of alpha will be what? H upon d plus x, right? For this I want in terms of x, because I would equate x and will get the values in terms of h. So putting up the values over here, d plus x equals to h upon tan of alpha. Tan of alpha. From here x comes out to be what? H upon tan of alpha minus d. Similarly for the other triangle, I'll do the same and things will be much more easier for this because h upon x is the case. From here x comes out to be simply h upon tan of beta. Let me equate both of them. This is the first one and this is the second one. So equating both 1 and 2. So h upon tan of alpha minus d is equals to h upon tan of beta. I want to calculate in terms of h, so taking h part on one side. So taking h common, I have, this is 1 upon tan of alpha minus 1 upon tan of beta. I hope you are understanding this part. D on the other side, this on this side. So from here, now we have 1 upon tan alpha minus 1 upon tan of beta. So what I can do for this case, with this particular case, when I do the calculation over here, the calculation will be simply, this h will remain in multiplication. So when you do the multiplication, you'll have a common denominator of tan alpha into tan beta, right? This will be the common denominator, and in the numerator we'll be having tan beta minus tan of alpha. But when I observe the option, no one option matches this one. But in the option I can see cot alpha and cot beta. So basically I can convert 10 in the cot. So let me convert 10 in the form of cot. I'll write tan alpha as 1 upon cot of alpha, and similarly for tan of beta as 1 upon tan of beta. This is not 10, 1 upon cot of beta. So when I put up the values, so this will become 1 upon cot of beta minus 1 upon tan of alpha upon 10. So this becomes 1 upon cot of alpha into 1 upon cot of beta. Over here also this is 10, not 10, this is cot. This is cot of alpha. Cot of alpha. Let me rectify over here. So this becomes cot of alpha. Now you take the LCM over here. This is cot beta into cot alpha if I have to write over here. So what happens when you take the LCM over here, cot alpha into cot beta? So cot alpha minus beta, cot alpha minus beta upon cot alpha into beta upon 1 upon cot of alpha into beta. So 1 upon cot of alpha into cot beta would be cancelled out. The final expression which I will be getting is d is equals to h. D is equals to h into cot of alpha minus cot of beta. Cot of alpha minus cot of beta. And since I need the value of h, so h will be what? D upon cot of alpha minus cot of beta, which matches our option of 2. D upon cot of alpha minus beta. A good question. Basically it was more of a trigonometry over here involved in this problem. That's all.